Hello, so this is going to be the guided video for how to create the PolySat Newb ruler on Altium. So, you should have access to the document with the Newb ruler instructions, and this video is basically just going to be walking through that process and possibly going into more detail about how to complete certain tasks inside of that instructional document. Okay, so let's get started. First, let's close this. Okay, so we're going to start from scratch. File, new, project. Name the project. I'm going to go ahead and do Newb. Oh god. Newb ruler. Let's do Newb ruler 1. No. 0. Okay. Create. Once you create the project, you'll want to add new to project and add schematic. So you'll see this blank schematic sheet. This area right here is where you're going to want to just document, of course, the name of the project, the revision of the project, and then who did it. It already has the date and the name of the actual file, so you really just need to enter in the information that I just described. So you press this A right here, just place text, 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 double click to edit, and you can just immediately go type in your name. You can see the text is changing over here, and then when I press enter, it'll register over here. This is going to be revision 0, and the title will be Newb ruler. You can change the text size, of course, right here, and also the font. I'm going to go ahead and change Newb ruler to be like, there we go, and then revision as well, just because the boxes are bigger. Oh god, no. There we go. You can, if you click, click and drag the text, you can move around. Okay. So, next we're going to want to add the libraries to our project so we can start adding components. You should have already set up the PolySat libraries, so hopefully this will be easy. And if you have any other problems, you can probably reach out to a lab member or an EE member to help you figure out the libraries. But add existing to project, and then you're going to want to navigate, the PolySat parts database. I believe mine is in my Altium folder, actually. Right here, just click that, open, you're going to see a new libraries folder, and your database is going to be in there. We're going to want to do this again because we have the database library now, but we're going to want the footprint libraries and schematic libraries. You don't always need this, but it's later on when you're maybe problem solving a footprint or schematic issue, you're going to want these added. Okay, add existing to project. Let's see. Navigate to wherever your PolySat SVN is, PolySat, electronics, lib Altium, and then just select PolySat footprints, PolySat symbols, open, and you'll see new PCB library, new schematic library. Okay, now we should be ready to place parts. I'm going to be placing mounting holes, and also I'm going to be creating like a specific schematic and circuit design, just as like a demonstration for how you would complete a schematic and then a circuit design. But you don't necessarily have to do the exact schematic and components and everything that I'm doing. Though it'd be fine if you just copy what I'm doing. I had a list of the components and everything in the document, so it might just be easier for just to start out or just to practice to just use my components and use my design. Up to you. Anyways, so we're going to place part. So right click, place part. And then you'll see this components tab open up. You're going to want to go to this drop-down menu and find PolySat, list of PolySat parts databases. Click miscellaneous. Ooh, I already have a search up here. Okay, in miscellaneous, of course, you're going to have to see all these list of parts. We're going to start with mounting hole, and it's going to be MT hole, and then we're going to do the 71 mil mounting hole. You just click, left click, and drag it, and there it is. Easy. And then I'm just going to copy and paste it. And now we have 4 mounting holes. So you see these red lines. This is because, of course, these ideally need to be numbered, MT1, 2, 3, 4. And to do that, we're just going to go to Tools, Tools, Annotation, Annotate Schematics Quietly. Yes. Easy. Done. Okay, so we have our mounting holes. Now we're going to add all of our different parts. So I have a list of parts again in the document, but I'm just going to go through this without, I'm not showing the document, but you'll see me like typing in the numbers. And of course you have access to the document if you would like the list of parts I'm using. So place, part. The first part we're going to find is in miscellaneous again, and it's going to be a red LED. Let's see. C170. There we go. Easy. Drag. Oh, click. Drag. There we go. Cool. Next, so keep in mind this is specifically the database with like accessing miscellaneous parts. So if you want capacitors, resistors, you're going to have to change which like part database section that you're in. So I want to get, and I'm going to use a 555, so I'm going to the ICs, and it'll give you the exact part. Okay, 555, cool. You'll see, of course, these red lines are because the parts aren't annotated yet. I'm just going to place all my parts and then annotate schematics quietly after all my parts are placed. Okay. Next is capacitors. This one is long, so I'm just going to copy and paste it from my document. So you'll see here, of course, this is a specific part number, and it has a description with, of course, like the information for the capacitor. It's also down here. But the footprint for the capacitor doesn't have that information on it. So to solve that for now, we're just going to go ahead and, in this comment, edit the value to be the unit for the capacitor. And then and see that it's not showing here, so we're going to uncheck this like I crossed out, or we're going to check the I, and then now it's visible, and our part's labeled. That's very important. You want the part to be labeled, of course, and you want its units. So definitely make sure if the part does not already have some sort of label, like this would be this LM555, that's a good label. And this didn't have that. So if it's not labeled, you'd want to make sure to do that manually. Okay, place another part. Okay, now resistors. Again, so right click, place, part. Those red lines, annotation. Okay, cool. So let's see. So placing all of these components where we want them. You can rotate components by left clicking, dragging, or just left clicking and then spacebar. Rotates the components around. You can also, of course, rotate ICs. I'm going to actually flip this upside down to make a prettier schematic. Okay, we have our components where we want them to be. Before I'm going to connect all of them, I'm actually going to place the ground and power port symbols. So go up to this red thing here, ground power port. I'm going to right click and then place ground power port. The ground is going to go, you can also spacebar again to rotate ground around. Okay, now I'm going to place the power port, so I'm just going to do place plus 12, and then I'll change this later to be plus 9, because we're not using 12 volts, we're using 9 volts for this. Okay, here, yeah, there, cool. Go ahead and double click this. You can see over here in properties, name is plus 12, just do plus 9. And here, plus 12, plus 9. Cool. Now, to connect all of these, go over here and press this like weird squiggly, 2 squiggly lines. Press that, and of course you can see that X on my mouse, so that's just going to be the wire. So click one end of a component, the other one, and now they're connected. This one, click at a corner to do like a right angle corner, and then this is going to go right to ground. So before we make the PCB layout, we're going to want to confirm that we have the correct footprints for all of these components. So for example, double click this, we're in the Properties tab. In here in Parameters, you're going to want to look at footprint. Of course, here it says the value of the footprint is LM324, but we're LM555, so it's not the correct footprint. Also, we're going to show the footprint to get a preview, and it says footprint missing. That makes sense because it's the wrong footprint. So come down here, add footprint. I think it's loading. Okay, I'm gonna have this pop up, footprint model, browse, and then you're gonna see this drop down menu. If it doesn't say PolySat footprints, just drop down and select PolySat footprints. This is where adding the footprints earlier on is gonna be very useful. I know that it's gonna be LM555. That, and then now it'll load. Yeah, okay. And we have the correct footprint, and we have a preview right here. And do the same thing for all of these. Okay, we've confirmed all of that. So now to create the PCB, we're going to want to go back to our Projects tab over here, down here. Do Add New to Project, PCB. Here's your PCB. Save to the project. Make sure you're in the projects. Newb ruler looks about right. Okay, now go back to Sheet. So to add our components from the schematic onto the PCB, it's pretty easy. Just go to Design, Update PCB Document, and you're going to get an engineering change order. And it's going to have all the components and all the nets. I usually do validate changes. It just makes sure everything has no errors. And then after this, you'll do execute changes. Okay, great. So now it's going to take you right to back to the PCB, and you can see all of our components right here. Currently, this little box is like, it's just like a container, I guess, to hold the components. I'm not really sure why they have this, but right-click this, go to Properties, and it says Keep Objects Inside. This means that when you move the objects outside of that red box, there'll be like an error. So we're going to want to change that. Keep objects outside, and now once we move the objects out of that red box, there won't be an error. Though, of course, now there's currently an error because they're in the box, and we just made it so that they should not be in the box. So we can just move this box. Easy. Done. Before you start, well, you can lay these out first, but I would recommend we have PCB design rules that are pretty well maintained in PolySat, and we have a document on Xserve. It's linked inside of the instruction manual for the Newb ruler. you should definitely go through those design rules. Okay, so before we place our components, we're going to want to define the board shape. So in order to do that, the easiest way would be to change the grid of the whole system here. So for example, press G. Here you can see all these different dimensions. If I do this, you'll get a grid system of 1 millimeter squares, right? If you already know the dimensions that you want your board to be, like for example, I know that I want my board to be 5 centimeters by 15 centimeters, just go to press G to change the grid, do grid properties, and then set the grid. I'm just gonna do like 5 centimeters, which is like insanely big. And now we're going to go to, let's see, board planning mode in view. Then board planning mode, while the board is green, design, redefine board shape. Now, when you're redefining board shape, you have to click to define the board and see I've redefined it. You might have just noticed that because I made the grid so huge, I can only change the board shape in increments of 5 centimeters, which is going to be useful because I only my board dimensions are in 5 centimeter increments. So okay, redefine board shape. 5 centimeters wide, 15 centimeters long, and then left click to finalize the board design, and then there you go. You've got it. 5 centimeter by 15 centimeter board. Now we can start placing our components. So just go back to view, 2D layout mode. Cool. So now we can start placing our components. Reset the grid, because as of right now, like if I tried to place this, I think it would literally not work because the grid is way too big. So G, I'm gonna actually do 10 mil right now because I'm gonna place the mounting holes and I want them to be exact. Okay, my mounting holes are placed where I want them. So now I'm going to place the components. So just click these and drag them onto here. You can actually just select all of them, drag them onto here. These lines define the connections between all the components. So you can see here, it's kind of nice. I can see like I can drag it, press spacebar to rotate it. Here, it's like kind of tangled, so just gonna like untangle, press spacebar. Yeah, looks clean. So you can look back at your schematic if you want to remember where your components are, and like typically, of course, when you lay out a schematic, you want to lay it out approximately how it'll look on the PCB. So I'm just gonna do just that. Okay. So have the layout, I'm happy with this. Notice these huge texts next to the components. Double click to get to the properties, and then I would change the text height and width from 30 to 30 mils height and 7 mils wide, and then just move it like to the side. And do that for all of them. Okay, happy with that. So now when we want to connect or create routes between all of our components, we're going to come up here, this right here, interactively route connections. You can see that it very nicely kind of just gives you the center of like this pad, and then it'll give you the center of this pad, so just connect them like so. Okay, everything's connected. Yep, nice. No errors. If you did have an error, some of these components or maybe some of the connections would look green. So we have no errors, that's great. So now we're going to create our polygon pour. So go to place, polygon pour. And now we can just use our mouse to left click and define the shape of our pore. Usually when you're doing polygon pores, try to make sure there's no right angles anywhere. There's about to be one right there that I'm gonna fix. Left click to complete it. And then over here in properties, it says no net. Make sure you change that to be ground. And then left click. Cool. So we have all this, we have the pore. So now we're going to add vias. These vias are just going to act as like the power source and ground connections for the component. Over here, there's going to be place via. Just going to do 1, 2. Double click the vias, change the net. One of them is ground, of course. One of them will be, nope, come on. 9 volts. Cool. Go ahead and take this right here, this A, place string. 1 second. Why is it red? Double click, make sure that these are in top overlay. These should be yellow. Cool. This is going to be labeled ground. And then this is going to be labeled 9 volts. Cool. This should be the ground. Does this have the net? Oh, it doesn't have the net. Ground. Enter. Okay, there we go. Notice that before these were not connected to the polygon, and neither was this via, but once I assigned a net to the polygon, it had a direct relief connection to the vias in these pads. Okay, this 9 volt, we're going to need to connect these. Go ahead and create a trace. Looks about right. So that actually will conclude this circuit design. In order to just make it look cleaner, I'm going to add a top overlay, and just, so I click this line thing, of course I made a top overlay, line width is 7 mils. I'm just going to outline this design. Okay, so now we're going to do the ruler design. So kind of similar to how we did the board design earlier, I already know that I want a ruler that has like a measure for centimeters. So I'm just going to go press G for grid and do, well, not 1 millimeter, right? No, actually, yeah, we can just do that. 1 mil, go over here, use this line tool. Again, make sure you're in top overlay. And yeah, I think 7 lines is still fine. And I'm just going to do, start like here, and then just drag down. So that's going to be 1. So left click here, and then right click to release the line. So like 1, 2, and then it's loose, so right click to release that line. Okay, either way, back line, okay, 1. Cool. So we have the beginnings of our ruler, right? So label it, of course. It's going to be 1. Do I want to do that? Yeah, sure. 1 centimeter. I'm going to make it my, my preferred size. Cool. So instead of doing that this whole all like doing every single millimeter, I'm just gonna select this, Control copy, and then and when you're copying something, you have to like define the reference point for the copy. So I'm going to define it as this here, and then notice that when I paste, like my little selection tool, it's at that end where I defined it earlier. So that makes it easy, so I can just line it right up to the end of the last measurement, go there, and then just do that all the way down. There's my ruler. Looks nice and pretty. So this ruler, of course, it's not just a ruler. We're going to use it to have, it's going to be useful for also like showing different like via sizes. We're also going to use it to display different pad sizes and then different trace sizes for like the different options for how thick your traces can be, or how thick your like silk screen lines can be. So we're going to do that right now to create basically just a diagram of varying silk screen like line sizes that you can have. So we're just going to start with this, and we're going to do 5 mil. Oh wait, crap. Does not say 5 mil. 5 mil. And we're just going to go like 1 to here. Okay. And then I'm going to do 10 mil. And I'm probably just going to do this in like 5 mil increments up until we get to 40 mil. Okay, so now we're going to label all of these. 1. Next, I'm going to create a diagram for different text heights that you can use. I have like a kind of common ratio of, or like I have like a list of text heights that I use. So I'm just going to do those. And it's like 20 mil to 5 mil, 25 to 7, 30 to 7, 40 to 10, 50 to 10, 60 to 10. I just do that. That's done. Okay, so now we're going to create a diagram of traces. So it would be like copper traces. It's going to be very similar to this, although I'm going to change the sizes a little bit. And then this time I'm going to go ahead and use the trace tool. And then over here, I'm going to change the width to be 8 mils, which is really like the smallest the traces ever get. 8. Come on. What's that? Okay. Yeah, okay, cool. 8 mils. Make that a little bit bigger. And then we're probably going to do 8 mils, 10 mils, 12, 20, 30, 40, 50. Place these how I want them. These seem to be really close together, so I'm probably going to alter spacing. Okay, that looks better. Cool. Okay, so if you press the number 3, this is like a 3D model of the board, and you can see that like over here we have this copper trace that's visible, and over here it is not visible. So in order to make it visible, press 2 to go back to the 2D mode. We're going to have to add, or make this, add like a top solder layer to this. So just select all of it, copy all of it. I'm going to make this my reference point, and I'm just going to like paste it over here. Select this, and then go over here for layer, and its top layer, make it top solder. Then just copy this again. designator there, paste it right there. Okay, so we like created a top layer and then, or no, a top solder layer, and then added it to this. I'm going to delete this, and then now if we go into the 3D view, you'll see that this is like a copper layer that's actually on the surface of the PCB. Yeah, okay, cool. Go back to 2. Now I'm going to do a via diagram. So over here is the place via. It's going to place, let's see, how many do I want? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, yeah, reasonable. So one of these is going to be 7 mils, no, 15 mil hole size, 15 mil diameter, 7 mil hole size. This is going to be 10 mil hole size, I think like a 20 mil diameter. This, you really like don't need, well, maybe 45, but you really don't need like super huge vias. So this, at this point, this is kind of just for effect, but. Okay, in order to straighten all of these, I'm just going to do a really large grid again. Okay, seems good enough. Make real smaller just to even this out. Okay, and then now, of course, label all of these. I'm going to label them by hole size, but you can do diameter and hole size or whatever you want. Yeah, let's see. The last thing we're going to be adding will be like a diagram of all of the different, or like most common capacitor and resistor footprints. So in order to do those, we're just going to go up here, place component, and then this time we're going to go to the PolySat footprints library. And you can see here, it's just like C0402, 0603, 05, 0805, etc., etc. So I'm just going to drag each of these here. Go back to place component, C0603. And then just repeat this, of course, and do all of this for the capacitors. And then if you scroll down, you should find all the resistors here. Just do the same thing. So we have our trace diagram, text diagram, like general silkscreen line diagram, and then of course our via size diagram. So that is really all we would recommend. Of course, you're going to have to put your name on the board. So let's go ahead and do that. Do 2, 3. So you would want to label who drew the schematic. And then the PCB, you did the PCB. Okay, so do the schematic, and of course write your name, you laid out the schematic, PCB, your name, you laid out the PCB, and then the title of the PCB, Newb ruler, revision 0. This. All of this is going to go right here. Okay. Cool. Looks good. You might want to, because I did this on my ruler, we have, of course, like this in centimeters, and you might also want to add like a ruler of mils, like 100 mil, 200, 300, 400. It wouldn't take long. It would basically be the same thing. Just change your grid to be like, yeah, like 100 mils, and then just draw the lines. Pretty simple, easy. Okay, yeah, this would conclude the tutorial for how to make a Newb ruler. There will probably be other tutorials in the future of how you would want to export this, how to export it as a Gerber, ODB++, etc. If you want to see this kind of like what it would probably look like in real life without having to order it, you can always press 3 and then see our like final board look. Looks nice. Hopefully you're also happy with your board design. Okay, cool. Thank you for watching.